in the fire alarm with 8051, a smoke detector is connected to interrupt pin. So I can program 8051 in interrupt mode. Keep that in mind. I am using external interrupt here in this program. So what we have done is we just enable that interrupt using this two line of the code. Okay, so whenever there is a falling gauge on external pin, okay, or a low level on the external pin, at that time my interrupt will trigger. And as my interrupt will trigger, what will happen? It will automatically go to the its interrupt service routine. Okay, which interrupt service routine will go? It will go to the one in which it should be going. Like for an example, if external interrupt 0, then it will go to interrupt routine service number 0. Okay, and there are some other numbers we have seen that in last lecture. Okay, so these are the other numbers. External interrupt 0 is number 0, 1, 2, 3 and 4. A total 5 interrupts, and you have to mention this number at this place. But we have done this program, even we have given an interrupt, and we have seen that that file alarm always like keeps on. Okay? And that was the issue, and we did not know why that happened. That happened due to one single reason, and that reason is whenever I say interrupt is occurring on pin P3.2 or pin 3.3, or I can say INT 0 pin or INT 1 pin, at that time there can be two different kind of signal which can trigger an interrupt action. What does that mean? That means if you remember the interrupt pin, that was what I can say active low type of pin. Okay, we have seen that's a bar over there. So whenever I give a 0, the function got activated. Okay, that we have seen. But there is a different side of the story, and that story is it can have two kind of trigger or two kind of signal whenever it goes low. Okay, so now you might think, if it's going low, how there can be two type of different triggers. Let me explain you that. So, we have seen this. It's active low pin. This two pin are active low. INT 0 bar and INT 1 bar. That means whenever I want to interrupt, the status of this pin should be going low. One example, if there is my smoke detector, whenever it detects a smoke, what will happen? It will send a low to this one. Otherwise, all the time this signal would be high. Okay? That means the connection between these two would be on plus 5 volt. Whenever the smoke detector send the signal to 8051, at that time it will send a 0 level signal, okay, or a ground to pin 12, and then my interrupt action is there, or that's the event of doorbell. When this signal goes low on this pin, that's the event of doorbell in our example. Okay, so basically it requires a low signal, but there can be two different type of low signals. And what does that mean? That means if you closely look at the low signal, let me do it just a minute. So how can be there a different signal? If the signal is low, then how can it be differentiated into type? So basically, you may have two type of signal. The first one is level, and the other one is known as edge. What does that two word means? For example, if I have a signal like this, let us say this is my low signal. Okay, so this is the moment when my interrupt start. This is the moment when my interrupt occurs. Okay, or let us say interrupt. And if you closely look at this signal, there are two different kind of signal in this single signal. The first is edge, and that is this edge. Okay, this part is known as a falling edge, and the other signal is this part from starting from here to this point, and that is a low level signal. Low level. So there are two types of signal. Okay, the first one is edge signal and the other one is level signal. So what's the difference between that? Okay, what's the difference in this one and what's the difference between this one? So the difference is very basic. If you go for the interrupts, and if you select this type of falling edge trigger, okay, so this is basically called as a trigger type. Okay, it's known as trigger type, using which kind of trigger I want to have interrupt. So it can be set to level trigger, it can be set to edge trigger. Okay, that decision is on you, which kind of signal you want. Okay, but if it's a level trigger, the interrupt will behave differently. If it's edge trigger, it will different, like the behavior would be different. So how that behavior would be different? So the first thing is, if it's a falling edge, if you closely look at the signal, this whole signal starting from here to this point, there is only single falling edge. Okay, there is only one falling edge throughout the signal. That means if you select this kind of triggering type, edge triggering type, in that case, you will have only one time interrupt. What does that mean? That means whenever this particular moment, when your signal goes from high to low, it will like trigger for one time. Okay, and your interrupt service routine will be executed one time only. Then what will happen if it's a level trigger? What happens if a level trigger? If it is a level trigger, what will happen? Let us assume my ISR is 6 microsecond long. Okay? I'm just assuming which ISR? This one. This part is 6 microsecond long. I'm assuming that. Okay, it's not 6 microsecond, I know that, but I'm assuming that this part is only 6 microsecond. So what will happen? Let's assume this signal, okay, starting from this point up to this point is, let us say, 100 microsecond. What will happen initially? If it is a level trigger type, if it's a level trigger type, in that case, what will happen? Your interrupt will occur at this moment when your signal goes low. Okay, now it is level trigger. That means it will see a level, a low level or a high level is a level. Okay, so it will see this. Then what will happen? It will interrupt. It will interrupt 8051. Okay, now my 8051 will go inside ISR. It will execute this instruction in 6 microsecond, and after 6 microsecond, what will happen? See, the signal is still low. That means it will interrupt again. Okay, after 6 microsecond, it will interrupt again one more time. Okay, so until and unless your level goes high back, you are receiving your interrupts continuously. Okay, even though it should be like one time, but as it is a level trigger, what it sees a low level. Whenever it sees a low level on your interrupt pin, it will immediately trigger an interrupt, and that's why your ISR will execute continuously up to the time when your signal is low. Okay, so for this whole time, it is receiving your interrupt. Okay, once it reach here, then it will stop interrupting your 8051. Otherwise, what will happen? Whenever your signal is low, it will continuously interrupt your 8051. That's the difference between edge trigger and a level trigger. Okay, so whenever you want your task to be executed only once, for an example, if I want to like have my fire alarm only once, then I'll go with this type of interrupt. But if I want that my fire alarm goes like it should be goes on continuously, then I'll be going with level trigger. Okay, so that's two kind of different signals which can generate an interrupt, a level trigger or an edge trigger. You have to decide which one you want to take. So if I select edge trigger or if I select a level trigger, I have to do the required settings to set up this level trigger or edge trigger. Right now, this program is level trigger type, okay, and that's why it's continuously bringing up the fire alarm. If I run this code, let me run this code. I'm going to run this code, and right now see your fire alarm is off, but as soon as I trigger it low, it is on, and it's going on continuously up to which time? Until this pin is low. Okay, P3.2 or my INT pin is low. Up to that time, it will trigger the fire alarm. Okay, as soon as I pick it up back or the level is high, your interrupt will stop. See, okay, you can see that. Now let's see the like whether this is correct or not. Let's see that. So what will happen if this is executing continuously? What will happen? It is going on and then it's going off back. Okay, so on and off is occurring inside that. Okay, so it should be like that. So let us see whether it's happening or not. The signal name is fire alarm. So I'll hit fire alarm. Now what I'm going to do, I have a breakpoint here and I'll run this code. Right now you can see your signal is like 0. Why it is 0? Because no interrupt action is that. Okay, now I'm going to have an interrupt by getting this low. As soon as you get this low, you have this peripheral here and you can have your interrupts. Now you can see this P3.2 INT 0, it's enabled. Okay, because I have enabled it by writing this line EX0 equal to 1. Your global is enabled, so EA is equal to 1. Let me use a magnifier if you are not able to see it. Okay, so right now this is enabled. Okay, P3.2 is enabled. There are just different type of interrupts. This all are the type of interrupts. Okay, which one we are interested in? This P3.2, INT0, timer 0, INT1, timer 1, and this 2 for the serial. Okay, now if you see this, it is enabled. This is EA. Okay, so EA is 1 and EX0 is equal to 1. Due to this EX0 is equal to 1, it is enabled. Okay, now whenever I get this signal low, it will request an interrupt. Okay, so you will see one here whenever I get this low. Okay, you can see this one. And now if I run this, request will be still there. Okay, you can see this request is still there. I'm going to run this code throughout and still your request is still there. I'm going to run it again. That means until your signal is low, your 8051 continuously interrupt. Now I'm going to pull this high back and see your request is gone. Okay, so this is the pin from where you can generate interrupt. If that signal goes low, it will continuously interrupt your 8051 if it's a level trigger type. If you don't know how to trigger it in falling gauge trigger type, then by default it's a level trigger type. Okay, and due to that you can see this kind of signal. Okay, once we set it up for the H trigger, I will have just one time execution of this whole loop. Right now this loop is going to execute multiple time. Okay, and due to that you get this kind of signal. Okay, I'm going to zoom in a little bit and you'll see the signal. You can see it's like going on. It is like on for some time and then it goes off again. It goes on again. It goes off again, on off. What does that mean? That means it executes this loop here. Okay, it start with one. It's waiting for some delay, large delay, and then it's going off. What will happen? It will try to go back here inside a while one. But as your signal is still low, it will interrupt again and it will come back here again. So again, immediately it will turn on the alarm once again. Okay, so this is the action happening inside your 8051. Okay, now we are going to see how to trigger it for the H type and what's the difference if I have it as H type. Okay, so first question is how to trigger it for H type, like how to get the H trigger functionality. So I'm going to show you that there is one resistor which we will be using for that, and that resistor is TCON. Okay. Even though it's a timer control resistor, then also it is used for your interrupt. Okay, it can change the type of interrupt. Okay, this one. If you remember, we didn't discuss about the other 4 bits of TCON register. We have this. We know what is TR. We know what is TF. We know what is TR. We know what is TF. We know this 4 bit, but we don't know this 4 bit on the other side. So what are that bits? That bits are related to external interrupt. Okay. This IT is specifically interrupt trigger type. Okay, or you can say interrupt type. So by changing this by modifying this bit, I can change my type of trigger. What I can change is either I can have a low level trigger or an edge trigger. What's the difference? If it's a low level trigger, until and unless my pin for the time my pin is low, I'm going to have interrupt repetitively or more than once. But if it's a edge trigger type, only I'll be interrupted only once throughout the low signal. When your signal goes from high to low, that single moment I'll get an interrupt. That means my ISR will be executed only once. If I want to interrupt it again, what I have to do, I have to again pull the signal high and again pull it low. Okay, so by making it high to low transitions, I can interrupt the thing. Otherwise, it won't be interrupted. So this is the bit from which I can control it. Okay, so if this bit is zero, that means I write a zero over here in this place. In that case, my trigger type is level trigger. That is happening right now. Right now, by default, IT0 is 0. That's why it is level trigger type. But if we want that my trigger type should be edge, in that case, you have to write 1 over here. So if I write 1 at this place, my trigger type will change to edge trigger. Which edge it will detect? It will detect high to low transition. That means a falling edge. Okay, this one here. The signal is high and then it goes low, so it will detect this falling edge, and this is known as rising edge. When you low to high as rising edge, but it won't detect that. It will just detect this falling edge. Okay, now let's read it out. It's interrupt zero type control bit set cleared by software to specify falling edge or low level trigger external interrupts. That's the only description given. That means if you write 0 here, it's a level trigger type. If you write 1 here, it's a falling edge trigger type. Okay. What's the other bit? The other bit is the flag of this one. Okay. So interrupt 0 edge flag set by hardware. So it's set automatically when external interrupt edge detect. Cleared when interrupt process. That means whenever it is an edge trigger type. Okay. That means I have written 1 here. At that time, whenever a falling edge appears, at that time this will be set 1, and this is the source of your interrupt, and once interrupt is cleared, it will get 0 automatically. Okay, so this is basically a flag of interrupt. When it will set only for the edge. Okay, that means if my signal is low, it won't detect it. It will go only high when there is an edge. Okay, and every low has edge. Like if I have make it a trigger, a low level trigger, then also I have this edge, and due to that edge it will set. So that's the difference. Now let's try to make this program, or have this program in external falling edge trigger type. So how I'm going to do that? By simply writing one line, IT0 is equal to 1. If you write this line, what we are doing, we are like external interrupt is trigger type. Okay, so this is the thing that you have to write. If you write this line, it's a edge trigger type. Now what will happen when it's edge trigger? Even though your signal is low, then also you will be only triggered once. I'm going to execute this code. Let's see that. Pressing F7, Control F5. Okay, now I'm going to again run the same code, and we'll see what happens. See, now my code is running, nothing is happening over there. Okay, I'm going to trigger it from here. You can see there is a single pulse here. Earlier what were happening, until this is low, you are continuously getting request. See, request is also 0. Okay. Why? Because mode is 1. What is mode 1? Mode 1 means it is falling edge trigger time. Earlier this mode was 0, that means it was low level trigger, and that time I was having multiple executions. Excuse me. So this is the difference. If I make it H trigger type, what will happen? It will only execute it once. Okay, I'm going to zoom it out. Okay, I'm going to like have an interrupt again one more time. See, right now it is here. I'm going to interrupt again. So I'll take it a high. Okay, and then I'll take it low again. You can see again an interrupt occurred, and the interrupt ISR has executed. That means fire alarm goes on and it goes off. But once it's off, it's never going to come back on until you trigger it one more time by having a high to low transition. So this is high to low transition is right now it is high. I'm going to give it a low. Okay, this is how you use interrupt, external interrupt, okay, for your program. Now we'll see one more example. Okay, we are going to have one more example where I'm going to use my interrupt signal and I'm going to toggle an LED. Okay. Let's do it. Let's take a lab question so you get better idea. Okay, just a moment. Let me fetch the lab manual and then I'll give you a lab question. Wait for a moment, student. I am fetching the question. It will take 1 or 2 minutes. Good. So this is our question. The first question is to toggle the status of pin P1.0 each time falling edge appears on INT0 bar. Okay. The second way I can ask this question, the second way around is I can ask us like this. The same question can be asked like this. Instead of INT0, now what I'm going to give is see on Okay, and then I'm going to write P3.2. But how I have like how you know that's an interrupt question, because I will have this additional word here. Okay. If I want a switch on P3.2, I will give a switch. But right now what I've written is a falling edge. That means this P3.2 is interrupting, and if I am indicating a falling edge, that means it's an interrupt program. So this is the other way around how I can ask the same question. Okay, so we are going to solve this. The answer would be same in both the cases. Okay, so now we will try to solve this question. The first thing is we need to toggle the status of pin P1.0. Okay, so no LED is connected, but the status of P1.0 is to be altered, okay, or toggle. That means I have to declare P1.0. Okay, so although there is no LED connected, then also I am going to use an S bit along with LED, because I want to toggle the status of that pin P1.0, that is 90. Okay, 90 is the number, so I will write 0x90. Might not need this, so I'm going to remove this. I'm going to remove all the extra line of the code. 17. This is my basic code. So first line is 90. Okay. What's the other information? The other information is I'm going to use interrupt, because there is a mention of int0. That means I have to enable the interrupt. Okay. So that's a one-time task. So I'm going to do it here. E is equal to 1 and ET0 is equal to 1. Okay, so this is what this is enable interrupt that's external interrupt, enable external interrupt 0. Or you can say you add it to int 0. Please mute yourself. Okay, so what I have done, I have enabled the interrupt. Okay, done. As soon as you enable interrupt, whenever interrupt occurs, it will automatically go to its subroutine. Okay, so you have to write a subroutine. I'm going to write a subroutine void interrupt, or let's say external interrupt 0 underscore ISR. Then how I, like, this is just the name of the function, but how I declare that that's an interrupt function? By writing the interrupt keyword. So I'm going to write interrupt keyword, that's a special keyword, and along with that I'm going to specify number. As the pin is int 0, this pin is int 0 pin, that means I have to write number 0 here. What I have asked to do, if a falling edge appears on this pin, then it should toggle the status of this pin. So what is this pin? This pin is LED. Okay, so I want to toggle the status of LED if interrupt occurs. Okay, so if interrupt occurs, I want to toggle the status of LED. So this is the LED toggle. Now when it should be doing that, it should be a falling edge type. Okay, falling edge is given. That means I have to set up this interrupt in falling edge type. So I'm going to write IT0 equal to 1. And see, this is a program. Easiest program in your 8051 is as well. You just have to enable interrupt, set it type. Okay, this is interrupt type. Just have to modify your IT0 and you are good to go. Okay, any questions? If I run this code, what will happen? Each time a falling edge, that means high to low transition occur on INT0 pin, that time your LED will change the status. Okay, that's the program. I'm going to run this. Okay, I'm running this now. Zoom in a little bit. Okay, it's not visible. I have to set up LED because I have given the name LED. That's why I am monitoring LED. Let's close it. Okay, I'm going to run this code. I'm going to zoom out a little bit and let's see what happens. If I trigger this pin P3.2, what will happen? It will change the status. Nothing is happening. Why? Are we doing something wrong? No, I have to go. What we have done has been LED 9 E equal to 1, ET0, IT01, while 1 void external interrupt 00. Yeah, everything is correct. No, not at all an error. Then let's see. Let me check one more time. It should be doing like it should be triggering instantaneously. How come the timer is enabled and not the interrupt? Okay, yeah, see the issue is here itself. Please keep in mind it's EX and not ET. We are writing the external interrupt, so it should be EX not ET. Now it's fine. Okay, I'm going to run this code again, and now as soon as I trigger this pin, see you can see this level, it's a low level. Okay, again I'll go take back high. When I take it high, nothing happened. Okay, but when I take it low, it will interrupt and it will toggle the status. Why? Because I have written in the code that it should be toggling the status of a pin whenever I enter. Okay, so again high, again low. So when it goes low from high, it will interrupt once. Okay, so this is the moment when interrupt occurred. Then it comes here, it has changed the status of LED, so it's 0 earlier, now it's 1, and then it goes ahead. Okay, once it is 1, what will happen? It's inside while 1. When it will come back here, when again I provide a falling edge here, so I am going to give a falling edge and LED will change the status. Okay, any questions? If you have any questions, you can ask, otherwise I'll go ahead with the next program. Okay, no questions, that's always good. Okay, the next program is to turn on LED connection. Yeah, go ahead. What is that?
while one પછી આપણે જે એક
Yes, Manish, go ahead.
while one પછી જે આપણે કવી જે પેલા બ્રેકેટ બનાવીએ છીએ એની અંદર સેમિકોલન નાખે છે તો વન ટાઈમ ઓપરેશન માટે વપરાય છે.
મતલબ આવું
એટલે કોઈ પણ શું કહેવાય ISR છે અને વન ટાઈમ જ એક્ઝિક્યુટ કરવા માટે એ યુઝ થાય છે while one ને.
while one is for infinite, like this is my infinite loop. Okay, if my 8051 is doing nothing, it is executing this while one, but as there are no codes here, what will happen? It will like continuously jumping from here to here. It will go inside a loop. Okay, there is no loop, so it will come back here. Again it's true, the condition is true, so again it will go here, again it will come back here. But what will happen in background, the external interrupt will trigger it. Okay, so how external interrupt will trigger? By sending a low level signal to that pin. So as soon as low level signal pins come there, pins go low, your interrupt pin have a low level, immediately your interrupt will be triggered. How it will be triggered? Automatically. Why? Because we have set it up here. So what will happen? It will stop here. It will stop this task. Okay, that's a bookmark. It will save this task, whatever it is doing, and it will come here and it will execute some other code. Okay. If you want to see it, I can show it to you how things happen. Okay, I'm going to show it to you just what happened actually. Okay. Wait for a while. I have to write 2-3 lines of the code. So I'm going to use unsigned integer here. See, this is not the correct program. Okay, whatever I'm modifying is just for your knowledge what's happening inside. Okay, I'm going to write a for loop here, so you can actually understand what's the routine task and what's the other task that is happening inside that. So I'm going to have a 50,000 delay, and I'm going to have I++, and inside that for loop, I have one more for loop, let's say, where I have j is equal to 0, j less than 50,000, and j plus plus. Okay. What else I need is, let's say this is a loop inside where I am toggling one more LED. Let's say that's LED 1. This set of codes is just to know what happens, like actually what happens whenever there is interrupt. Okay, I'm going to declare the other LED be 91 and this should be J. F5. Now we will monitor this I and J value. Okay, right now it's here. Okay, this is LED. I'm going to one more. I have one more LED 1. Okay, what I'll be doing? I'll be single stepping this code. Okay. So now you can see this is incrementing, J is incrementing. Okay. As your J increment, you can see this one is toggling. Okay. So this is my routine task. What is it? It is inside while one. That means it is continuously executing this. Now what I'm going to do? I'm going to give an interrupt. How I'm going to get an interrupt? By having this pin low. So I'm getting a signal. Okay. Now I'm going to single step. See what happens. Okay. See your program counter come here. See your J value is constant right now. It's D and it's not moving at all. But your LED has turned off. The other LED that actually you wanted to turn off. So your routine task has stopped. You can see your J value is not incrementing. It's right now D. Okay. Let me use a magnifier so you can. I'm going to show it one more time. So here my magnifier. Okay. Right now you can see J is D. Okay. And this thing has toggle. Why this has toggle? Because I have given an interrupt. So actually it was executing this that is inside the while one. But as interrupt has occurred, it has stopped this task and it has moved to toggle this thing. Okay, again I'm going to have one more line of code. Okay, you can see J is still D, and again I'm going to move ahead, and at that time now you can see it has toggle LED, and now this will start to incrementing. Okay, let's see that. So you can see the difference here. You can see the difference here. Okay, now you can see this difference. Earlier, your LED toggling action was like happening every 7 microsecond. You can see this is also 7 microsecond. That means each 7 microsecond it was executing. But what happened here? Why this is so large? It's almost like 0.5, not 0.5. It is almost 9 to 10 micro. It's 14 microsecond. Okay. So what happened here is I have triggered an interrupt by writing this pin low. Okay, so as soon as I get this pin low, what happens? Whatever it is executing inside while one, it has stopped this task. So it has stopped the task wherever it was. Okay, and it come here. It has executed this code. Okay, so this code execution requires some time, and after that it come back here and it started executing it back again. So whatever time was taken here was additional time here. Okay, so earlier it was happening at each 7 microsecond, but when interrupt occurs it goes like the timer is large. Okay, I'm going to run this code continuously and you can see again interrupt, again interrupt. Okay, so whenever I'm going to interrupt, it will take a more time to execute. That's the thing. I'm going to show it one more time what happened. See, let me have this watch window out of here and press less it in. Okay, I'm going to reset everything. Okay. Now again, see what happens. I'm interested in this status of J. Okay, so I'm going to have J. You can see now J is incrementing continuously. On each count, J is incrementing. Okay, and your LED is toggling. You can see that. But what happened if I give an interrupt? If I give an interrupt, it will go to your ISR. Okay, so this is my continuous task, that routine task. It is right now in for loop, so it is incrementing j continuously. No interrupt, so it is doing its routine task. Now I'm going to ring a doorbell. Okay, how I'm going to give a falling edge here by writing this bit or this pin 0. So I'm giving a pin 0. Okay. Now I'm going to execute. You can see this 1A is stopped. Now it is not incrementing. See. But what actually it has done in that time, it has gone to your ISR. It has turned off the LED that you like. It has toggled the LED you were asked. Okay, this one on pin 90, so pin P0.0. It has turned off this one, and now it will come back to the routine task. So a doorbell occurred, like in your home you were there, your doorbell rang, you go to your door, you attended whatever is there, and you come back, and now you will start again from where you have left. So it has started with 1B. Okay. So on each click the count is like after each 2 click my count is incrementing. Okay, but if I provide a falling edge, then it will not increment for some time, and then it will start back again. Okay, so during that time my interrupt is occurring. Manish, clear? So if my while one is empty, actually it is continuously doing that task. Which task? It is just going back and forth inside of while one loop because it's blank. So it does not have any specific task to perform, but then also it is like continuously jumping from one address to other address. Okay, because we do not have any task written over here. But right now, if you look at this is a specific task written, and with this example, you can see how interrupt occurs. Okay, so whenever there is an interrupt, you can see the time is increasing. Otherwise, the time is uniform. Manish, clear?
Yes, clear.
Okay, anyone else? Any other doubts? If you don't have any doubt, what I can do is I can go ahead with the next program. That's question 2. That's a little bit different because there we are using two different at the same, like two interrupt at the same time. Okay, I'm going to remove this modification and I'm going to paste the code for your reference. This is the code for your reference, and I have a second question. Now, what's the second question? See, to turn on LED connected to port pin P2.0. Okay, so first we are going to declare that. So I'm going to declare port P. It's a 2.0. So I'll have number A. Okay. What I have to do now? See, if a falling edge appears on int 0. Okay. So if it's written a falling edge appears, that means it should be edge trigger type. On which pin int 0 pin, that means I have to enable that functionality. So I'm going to write void main. I'm going to enable the interrupt. This is a global enable bit, this is the local enable bit, x0 is equal to 1. Along with that, I'm also going to modify the type by writing it0 equal to 1. So if I write it0 equal to 1, what happens? It's a falling edge type. Now what's the other task? Let's see. A falling edge appears on int0. Okay, what I have to do? Turn on LED. Okay, so write down, let's write the ISR for that. If a falling edge appears on int0, what we have to do? We have to turn on LED. Okay, we have declared LED, we have enabled, like we have this set of codes which enable the interrupt. So I'm going to write the subroutine for that. So that's a void. Okay. Let's say ext0 ISR. I'm going to specify the special keyword interrupt along with the number will be 0. Okay, what I have to do? I have to turn on LED. So turn on LED is LED equal to 1, and I'm going to close this because there is no other task. You have to just do that. See, and now there is one more question. And turn it off. Who? LED. If a falling edge appears on int1, that means I have two interrupts right now. The other interrupts is int1, so I am going to enable this as well. And what I have to do if it is there, I have to turn off the LED. Okay, so I am going to enable the other interrupt. So now what I have to write? I have to write EX1 is equal to 1. That's the external interrupt 1, and IT1 equal to 1. That's a falling edge type on your external pin INT1. Okay. Now what I have to do? I have to write a separate ISR for that. So I'm going to write one more ISR here. Void ext1 ISR. Okay. Interrupt. Now which number will be here? Number
One.
1. No
One.
1. No. 1 is for timer 0. Which number will be that? 2. Okay. See again. So if you don't mug up this list, you will end up there. Okay. This is the list. External interrupt 0 is 0. Timer 0 is 1. External interrupt 1. Right now we are writing external interrupt 1. That means number is 2. Okay. So that's 2. What I have to do? I have to turn off LED. So I'm going to write LED equal to 0. Okay. And that's the end of program. Have you asked any other task? No, there is no task. So I have to wind up the program. Okay, so what I'm going to do, I'm going to have a while one. That's a blank. See, if I don't have this while one, what will happen? My program will generate an error. That's why I have to write while one blank. Okay, and this is the set of code. Okay, so this is end of my void main. This is my first interrupt service routine. This is my second interrupt service routine. You can have 10 number of interrupt service routine. Whichever interrupt you are using, you can have a separate interrupt service routine. So okay, I'm going to run this code. Control F7. F7. Control F5. I'm using port 2 and port 3. Okay, so I'm going to remove this one. I'm having port 2. This is my port 2. What will happen if I trigger INT 0? It should turn on, and if I trigger INT 1, it should turn off. Okay, I'm going to run this code. I'm going to zoom out. Okay, now what I'm going to do, I'm going to give P3.3. So this is 0, 1, 2. Let me have a magnifier. Okay, what I'm going to do, I'm going to have an interrupt of INT1 P3.3. So it should turn off. So it had turned off. Okay, I'm going to turn it back. Again, if that same interrupt happen, nothing will happen. See why? Because again it will execute the same line of code, and the only code written here is LED 0. You can see here. Okay, now if I want to turn on, what I have to do, I have to give an interrupt to INT 0 pin. Okay, so which is that pin? That is this pin, INT 0 pin. Okay, so I'm going to write that. Okay. So whatever interrupt whatever number of interrupt occurs here, nothing will change. Why? Because it's executing same task, LED equal to 1. So no changes over there. But if I give an LED INT is 1 a low, at that time my LED will change the status. So this is the program. Okay. If interrupt occurs on this pin, LED should turn on, and if interrupts occur on this pin, LED should turn off. And that's happening exactly as per my requirement. Okay. So this is the other program. Any questions in that? Any questions in the other program? This is the program. Any questions? Okay, then we'll stop here. We are done with the chapter of interrupt. Okay, what we have done with the timer, same we are doing here. The only difference is this type of interrupt was not in timer, but it is here. It can be a falling edge, it can be a low level trigger. Most of the time we will be having a falling edge. Okay, a low level trigger is very rarely used. Because whenever the signal is low, it's continuously going to interrupt, and that's an issue. Okay, but that may be advantage in some application. Okay, any questions? Okay, then we'll stop here. Thank you.